This video is over sections 2.6, linear regression, and section 2.8, linear inequalities. Okay, and my fourth period class wants to say hello, so everybody say hello. Hello. Okay, so a scatter plot is a graph of a set of data pairs. We just make a table of our data and then we plot it. We just plot the points. If y tends to increase as x increases, then the data have a positive correlation. If y tends to decrease as x increases, then the data have a negative correlation. And if the points show no obvious pattern, they're all over the place, then the data have approximately no correlation. In just a second, I'm going to go over one example of how to do this in our calculator, and I will give you guys a handout tomorrow with the calculator steps on it. But when you do this in your calculator, you're going to be able to see a correlation coefficient. And a correlation coefficient, which is denoted by R in your calculator, is going to be a number from -1 to +1. It measures how well the line fits the set of data pairs. So if your R is close to 1, the closer it gets to 1, the closer the points lie to a line with perfect positive slope. If your R is close to -1, then the points are close to a line with negative slope. And if R is around 0, if it's in between them, then the points do not lie close to any line. Okay, here we have a table of values. We've got a list of animals, and we have their average gestation, which, in case you didn't know, gestation is the amount of time that they spend in their mommy's tummies. And this list, it doesn't say, but this is in days. And then we have their average lifespan, and this list is in years, and it's okay that they're different. So we're going to enter this data into our calculator. This list will be the x's, and this list will be the y's. And so we're going to press Stat and then Edit. And then in list 1, we will put all the x values, and in list 2, we will put all the y values, like so. Then we're going to plot a scatter plot on the calculator. You'll press second stat plot, which is right up above the y equals sign, and then you'll hit enter. Turn the first plot on just by toggling it from off to on and hit enter. And then select the type of mark you want. It's defaulted to some dots, and that's fine with me. And then to graph it, you can hit graph, but it's not going to show you everything. You need to press zoom 9. That's zoom stat, zoom 9, and it'll show you a perfect graph. It'll zoom in on all the points that you've entered in. And so here's what it looks like. Now you're probably going to be asked to graph this by hand. So what you would have to do is just draw your x and y axes. You want to make sure you label them like that. Sorry about my really bad handwriting. It's hard to write sideways on an iPad with a stylus. But you need to make sure you always label your x and y axes, and then you can come up with a scale that works for the points that you have and just plot them by hand. All right, now we're going to calculate the line of best fit. So you're going to press Stat again, and then you're going to arrow across the top to the Calc menu, and you'll go down to option number 4, which says LinReg, and that's the linear regression. So that's going to give us a line. So you choose that, and you hit Enter, and it will calculate the line for you. It should look like this in your calculator. So what it's telling you is y equals ax plus b. It's using an a for the slope. So here's your slope, and you want to round it to 3 decimal places. And then b is your y-intercept. Once again, round that to 3 decimal places. And you can write that down, and that's the equation of your line. Now, your calculator may not show the r squared and the r, so if that happens to you, then you need to make sure that you go to turn them on, and here's what you're going to do. You'll press second catalog. Catalog is right up above the 0. And then you'll go to Diagnostics On, and you can either scroll all the way down to the D's, or you can just hit the D button on your calculator, and it'll take you there. So you go down to Diagnostics On, and you're going to hit Enter twice to turn it on. And then redo your linear regression, and then your R's should show up. And if you remember from the definition we wrote earlier, the correlation coefficient is the R value. So the R squared is a stats value, a statistics thing that we aren't going to use this year. We're just going to look at the R value. And if you look at this one, it is 0.600. So that's close to 1. It's not really, really close to 1, but it's it's closer to 1 than it is to 0. So this, we know this has a positive correlation, which we saw when we graphed it. You can look at the dots, they're going upward. And then I might ask you some questions like, if the gestation of an iguana is 12 days, what would be the lifespan? And so remember, our gestation was our x's, so we would just plug in that number for x and solve for y. Or I might give you the lifespan of something and ask you for the gestation, then vice versa, you would plug that in for y and solve for x. I also might ask you what different pieces of this mean. So like, what does the slope represent here? Our slope is 0.061, but what is that number? What does it mean? And so you have to think about the units of your slope. Your slope is your lifespan, years of life, per 1 day of gestation. And so this slope is saying that in general, animals have about 0.061 years of life per each day that they spend in their mommy's bellies. And you could write that, in a full sentence, however you wanted to write it. Okay, now we're moving on to the next section on linear inequalities. And a linear inequality in two variables with x and y can be written in one of these forms. These are in standard form, but it doesn't really matter which form you use. Instead of an equals, you're going to have either a less than or greater than, a less than or equal to, or a greater than or equal to. All right, an ordered pair is a solution of a linear inequality in two variables if that inequality is true. When the values of those two values, x and y, if you substitute them in and it's true, it works out to be less than or greater than like it says. So if I asked you, is this ordered pair a solution, all you would have to do is plug it in and see if it's true. Now, to graph an inequality, you're going to rewrite it, rewrite the inequality in slope-intercept form. You want to have the y part by itself because it really, you need that to know which way to shade. And don't forget to switch the sign if you divide by a negative when you transform it to slope-intercept form. Then you just graph that line as you would a regular equation. If it's going to be a less than or greater than, then you're going to use a dashed line. If it's less than or equal to, greater than or equal to, then you'll use a solid line. And then if it says greater than, you'd shade above the line, you'd shade up. And if it's less than, you would shade down. So let's do a couple of examples. Okay, the first one we want to graph is x is less than or equal to 5. So we can't put this in slope-intercept form. This is the equation of a vertical line, so we know we're going to draw a solid line through x equals 5, and then we're going to shade. If it's x is less than, then that means it's moving to the left. We're going to shade to the left, just like this. All right, the next one we're going to do, 3x minus 4y is greater than 12. So I want to subtract the x to the other side. Negative 4y is greater than, and then I'm going to put it over here, negative 3x plus 12. And then I have to divide everything by negative 4, which means I need to switch the sign. Y is less than. Negative 3 divided by negative 4 gives me positive 3/4 x, and 2 over negative 4 is minus 1/2. So you're going to plot the line with a slope of 3/4 and a y-intercept of negative 1/2. You're going to draw it in dashed, and then you're going to shade down from that line, like so. All right, now we're going to graph y is less than or equal to negative absolute value of x plus 2 and then minus 1. So we know how to graph this now because we did transformations yesterday. We know that this is the absolute value v reflected over the x-axis, shifted left 2, and down 1. And then because it says less than or equal to, we'll use a solid line and less than goes down, like this. So you see it is reflected over the x-axis, so it's going this way. It's left 2 and down 1 from where it normally was, and then less than is everything shaded below it. All right, and the last example I have for you is a word problem. You have two part-time summer jobs, one that pays $9 an hour and another that pays $12 an hour. You would like to earn at least $240 a week. Write the inequality describing the possible amounts of time you can schedule at both jobs. Graph the inequality and identify 3 possible solutions of the inequality. So we'll say the first job you make $9 an hour. The second job you make $12 an hour. So if you took X as the hours at your first job and Y as the hours at your second job, we know we want at least, so when you see at least, you know it has to be greater than or equal to 240. So we're going to graph that line, and it's going to look like this. First we will subtract 9x, and then we'll divide by 12. We don't have to switch the sign this time. Negative 9 over 12 reduces to negative 3/4 x plus, and 240 divided by 12 is 20. So here's your graph. And then when it says identify 3 possible solutions, because it's y is greater than, you want to earn at least 240, but it doesn't give you a cap. So any ordered pair that exists in this shaded region would be a combination. You could do 15 hours at your $9 an hour job, and you could do 30 hours at your $12 an hour job. Or over here, you could do 35 hours at one and 15 hours at the other. The only thing that wouldn't get you your $240 is anything that's in this triangle. So that triangle gives you all the combinations of hours that won't earn you enough money, and then everything else would be. So 3 possible solutions are infinite ordered pairs that you could write down for that. And that's the end of that. So I'm going to let you guys go do something else tonight, and I'll see you in the morning. Goodbye.